So here we go. This is Thursday, 3rd of December, the 25th day of Pkt2. This is insane. I was putting together the Pkt2 organizer today, and it's at least 16 pages. Plus, you throw in the take-home test. You throw in the, now we're talking 20 pages. You need a big old honker stapler with that one. Before we get into the questions here, on the physics in the Canvas, on the modules, the first module says welcome to physics, and that's been there, but there's a page that I added. Well, it's your reference page, but I'm calling it equation sheets now. And if you click on that, one thing it takes you to is this, and this is all, these are the three so far, the three equation sheets that we have. We're going to end up with like 25 sheets, but it's, someone asked us, how, we only have 3 now, how are we going to have 25 by May? Well, it's sort of an acceleration process. The more physics you get under the belt, the more you can talk about it, and the more things come up. So we're finally getting to the point where we can start talking about, at least kinematics wise, we can start talking about some real physics. I already have 2 more sheets in the queue ready to go, but I want to wait till, like, you get to use the sheets on the test. So these sheets give away answers on the next test. So I'm going to wait till that, and then we'll end up with 5 sheets. We've covered about 6 sheets worth of material, but I don't, like I said, I don't want to just put the answers to the test. So this is on the thing is though, this is not a good version to print off. So if you go up to the second module, then I've added this one right here, and that is the equation sheets PDFs. So a good version. Now I know students at the high school, if you're there, if you're at the high school like some of you are on blended schedule, the library told me last year that they will print those off in color free for you. So you get, now maybe they don't have that money anymore, but they used to have money to print off free color copies for students if you don't abuse it, you know. So might take advantage of that, because these are better in color than they are black and white. All right. So I would print these out, take them into your notebook, at least staple them together and just kind of keep them close when you're working on homework, so you have something to refer to. You know, there's your equations. This shows you how to work problems, sample problems. So, all right. We did a dolphin stamps on these ones Eric asked about. We went around and gave those stamps out. Miranda, she wasn't here for our discussion yesterday, so she, you know, emailed me her homework. And the thing is about that, I can't, I mean, it's fine, but I can't take emails. I would have 25 emails a day just trying to look through homework, and that would be an hour and a half. I can't just keep opening up. See what I'm saying? So maybe what we'll do instead, how about this idea? Once the sheet is completed, then like we get all these dolphin points that kids are getting, and the whole point to dolphin points is that they are staying up with the material. But I just don't see a way without tons of emails and PDFs that you all could send me that. I thought about holding your thing into the camera, but then the kids that can't make it to these, and I do have other kids, Aiden goes and watches these every day, but they just don't, they're not available from 4 to 5. So that wouldn't be fair to them. So I think maybe instead, the only way I can think to do it fairly and you know, reasonably, is that I have the virtual students, once they complete a sheet, like a big dolphin stamp sheet is 212 so far. Then once they complete it, which we should be completing that in the next couple of days, they take a PDF picture of the front and the back, send it, and then email it to me. We're not submitting it through Canvas. That would just confuse all my kids in class. So with the virtual thing, you'd have to email it to me, and then I could give you dolphin points on those. The reason why you want dolphin stamps, I wouldn't actually stamp it, but I give you points. But the reason you want those is it is worth 20 points. I mean, that's some bonus. That's 20 points by December 16th. And anything above that, I would see which ones were dolphin, and you would get, a bonus. You start getting bonus next week. I have kids in class that are just now they're probably tomorrow start getting bonus on these. Okay, so that's the current status on dolphin stamps. We'll wait until that sheet is complete, and then you can turn them in, email them in to me. Just do it through the Canvas. It's easier. Not submit it, but attach it and email them to me through Canvas. That's where I'm at right now. All right, so here's where we were yesterday. We did a lot of talking about G's. I showed, I think, a video. I showed a video of the, okay, before we do this, let's go to the girl in the Jeep real quick. So in class, and I think in here yesterday, we were coloring in some of these. And so I made them get 4 colors out, and they had to color in the V versus T graphs. So did we color them all in? I don't remember.
No.
Okay, so you may not have, you should have colored pencils somewhere around the house. Go look in the old junk drawer. Look for some colored pencils in the junk drawer. If you have it, you should have a colored set of pencils because we do a lot of coloring in physics. Anyway, so we spent about 2 or 3 minutes in class coloring in these V versus T graphs. It's just like the finger dance. You got to first color them in. Those were like rectangles, but now they're triangles, which complicates the issue, as you see if you've watched the Girl in the Jeep video yet. So anyway, I colored in one as an example. So somebody asked in class, they said, well, wait a minute, why would I need 4 colors? It seems like a graph like this would just need 2 colors, right? You have a negative triangle and a positive triangle. And I said, yeah, that makes sense, except that every time something changes, you have to color it in. You have to color that as a different color, saying that, okay, now she's doing, this girl in the Jeep's doing something else. And these, I think these questions are answered on the video, but let's go ahead and look at them anyway. One of the questions here says, what is happening here, right here at this point? Why isn't it a minimum above? And it's not. Can anybody tell me what this is? Velocity. So obviously the velocity right there is, this is something we didn't talk about in class, but I told the kids in class, I said, if you want a more detailed description, because I'm not under the time constraints, here with you guys can always just drop off anytime you want, but I feel more relaxed and I'm not trying to, push I know where I've got to get. And anyway, so sitting here in my, study, the velocity here is 0, right? The velocity at that point is pointing to the 0. It's at the 0 line. So what's happening physically? Somebody try and answer that? The girl in the Jeep's velocity is 0, but what is she doing?
Did she put the car in reverse, maybe?
Right. So she either that or she turned around or something because she's going the other way. So remember the first quadrant in velocity versus time stands for forwards, stands for things moving forwards. I'll say 4. And the 4th quadrant stands for things moving backwards. So somehow she went from forwards to backwards. And I realize it defies logic that she could do it that quick. But we are not, this is still, we're getting closer to reality. This is more realistic than the finger dance. But anyway, so that's velocity. Now, the last question on this is what is happening right here and here? What the heck is going on there? And Dr. Fauci talked about these points yesterday in his news, in a conference or his interview with somebody, probably MSNBC or something. He was talking about this right here in here. What are these? What's going on in these two places? You've actually heard this one in your math class. You know what they call these in math?
Did she turn the car? Maybe?
No, she didn't. She did not turn the car. She did not turn the car around. She's still, this whole thing, all of this here is going forwards. She continues to go forwards. All of this is going backwards. But what did she do right here at the peak?
She let off the gas.
Okay, so she was pressing the gas. Daggone this buffering. She was pressing the gas. And I think this buffering, I thought, well, maybe it's because I have too much. I've been killing stuff right and left, thinking there's not enough memory, but I've got gigabytes of memory left. I don't understand. Anywho, so yeah, so so I like what you saw. I'm giving you a zoom point on that. She pulled her foot off the gas. She was speeding up and speeding up and speeding up, and then she's still going fast. She's still going forward, but she's not going as fast. So she kind of let off the gas. So this is called, as Dr. Fauci said, this is called a point of inflection. Or just inflection point. And I think you've heard that one in math class. If you haven't, you'll hear it this year in pre-calc. Point of, let me write that so you can read it. Point of inflection. Blow this up. Lost my mind. Here we go. Point of, boom, there we go. Point of inflection. Or inflection point. Now, does anybody remember what that means from math? That means steepest slope. Things are changing the fastest. So Dr. Fauci was unfortunately talking about the rate of hospitalization for COVID. And he said, we're reaching, or in this month of December, we will be at a point of inflection, meaning that we're always talking about flattening the curve, right? Well, that's the opposite of this. This is making the curve as steep as possible. And so that's where we're at right now with hospitalizations, is we're at this, skyrocketing peak, heading for this, hopefully, I don't know where the peak's going to end up. It's crazy, but we're at a point of inflection. Well, that's a point of steepest positive slope. Okay. So steepest positive slope here. And this positive. And this down here is also a point of inflection, but that's the point of steepest negative slope. All right. So we call them a POI. POI. And that is steepest negative slope. And this is also big in calculus. Okay. Okay, so then that if you can kind of look at this graph and go, okay, it's going to start off as a parabola. The graph I'm talking about, this graph above. You're going to have to plot this. So without even plotting it, I can tell you this much. Let me just kind of sketch it out. I know for this first little bit, and I'm going to put dash, 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 dash. Let me do that. Let me look at these are all the points where things change. The points at which when my color of my graph below changes, right? So there, here. Okay, whoa. My ruler's messed up. All right, here, 89. Okay, there we go. So here, and then here. So these 4 points, these 4 areas, then I guess I could color in blue, green, yellow, and I'm not going to do that though. But so we know that this then is some, I'm not getting the numbers right, but this is some kind of positive parabola, like we've seen in a lot of trios. Then this green, if I go with the green, I said I'm going to do it. Now I'm going to do it. This green area, I want to keep this up. Maybe I'll make them do this in class tomorrow. They're going to hate me. Not more coloring, Mr. Rasky. Man, you should color every day. You should color. It's I'm going to start a chain. They have these meditation places, right? Yoga. Well, I'm going to start a chain of places where you give them big color books and all kinds of cool colors and all kinds of cool coloring books, and we put on meditation music, and people color. They color, and maybe somebody comes along and gives you a shoulder massage, so it relaxes you. And then we'll bring in some goats. We'll bring some goats. Okay, so this goes up something like that. And then that's the steepest point. And then it starts to, she lets off the gas. So it starts to curl back around. And then the slope, remember this graph is telling you slope. And if this doesn't make sense, I explain it on the video I'm doing the homework for you. Great. But I explained it on the video. But this part right here, that's the 0 point. That's flat. So I've gone from steepest, and once again, my numbers aren't right. Hope you're not watching this without sound, because the numbers are wrong. This then comes up, and then it levels out somewhere, because it's got to be flat. That doesn't look very good, but it's got to be flat at that point, because this crosses the 0 mark. Then it starts to get more and more negative. And so the yellow region, I'm going down now at the same rate. It looks like the same rate I was going up. So I'm coming down. I must end up right there again. And now it's the steepest going down. And then it starts to level back out. And she ends up stopped. She ends up stopped here. So this level's, I don't know, to determine whether you end up in the first quadrant on the X versus T or the fourth quadrant, you look at these graphs down here. And you say, well, how does the area here compare to the area here? I don't know. It looks about the same. It almost looks symmetrical. So I'm going to assume that she ends up about where she started. So it looks like this kind of figure, that should be probably flat again. This kind of figure here on this graph gives you a bell-shaped curve on that graph. It's called this is called a bell-shaped curve. You guys should really take statistics. They didn't offer statistics in high school. When I was going through, I didn't take a stat class till I was in grad school. I wish I had, though. Especially now in science, everything's statistics. All things number crunching. That's what they do. They chi-squared, all that kind of stuff. They throw. Okay. So, I see I did that in the wrong class, but that's all right. So that's the homework. That's not due till Sunday. Now you are going to submit that Sunday. Okay. Let's get on. Let's get out of there. Oh, and so this is also, we went to the board on this. So our version on the Zoom of going to the board is me putting it on pause and you working on it on your papers. And this is where if I knew how to do groups, this is where we hit the group button. You go off and do your groups, but I'm not quite that sophisticated yet. This is from last year's test. And it bombed. Oh my gosh, this was a bomb last year. This ended up being a black problem because so many people missed it. But let's take a look at it. So you try it. It says sketch the following situations on the V versus T graph below or to the side. With a solid line, acceleration is negative. So you're going to show a line, not a curve. With a solid line, show a situation on V versus T, like the girl in the Jeep, where acceleration is negative and you're slowing down. And then with the dash line, show something where acceleration is negative, but you're speeding up. Okay. Now I'm going to hit pause. So we're not wasting dead screen time here. And recording. Okay, so we're resuming our recording, and I had them hold it up to the screen. So you're hopefully, if you're at home, you hit pause, you tried this. But what we have so far is one of the students said the dash line looks like this, dash, 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 and that is correct. But then he had the solid line looking like this. And the problem with that is I agree. He's correct in that it's slowing down. The blue line is slowing down, but that's not negative acceleration. That's positive acceleration because it's a positive slope, right? So, and then another student said, well, you would fix this if you put it in the first quadrant, but if you just move this into the first quadrant, that's positive. That's positive acceleration speeding up. So if I fix this by switching it to the first quadrant, but also flipping keeping it a negative slope, now I got it, because now it is slowing down. These are the kind of questions you would see on a AP physics exam. It'd be like I told you, the AP physics exam is 35 questions, multiple choice. Maybe they give you 5 choices, and these would be some of them. You have to choose the one, or it'd be part of a free response. Like those free response are part A, part B, part C, part D. But maybe in there they would have this as one of the, to have you do. So it is kind of a thinking kind of free response kind of question. Okay, so it could go all the way, but then I had some students do this. They did it like this, and they're doing great, and then they went, uh-oh, and right there they blew it. And on a test last year when I was grading it, that's what some students did, and they lost points. I had to circle this in red, say nope, 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 because you were right until you put the thing in the fourth quadrant. Then it's to turn around, like the girl in the Jeep, it's a turnaround point right there. And then all of a sudden she starts speeding up, going negatively. So you can fix this by just erasing that part, and now you got it. It could go down to the 0, but it can't go into the fourth quadrant. So I made that question up. I like that question. I made it up about 10 years ago, but every once in a while I come up with a good one. Okay, so quite proud of it, really. Now let's go to this, our virtual. Oh, and you were asking questions about 9A and 9B and I found I couldn't find a key that I had done for this. And then I realized, I put this worksheet together last year. This is kind of a hodgepodge of other sheets, and I stuck them all together in one sheet. And so I didn't have a key for it, but I noticed that I do have Miss Milligan's. I have hers from last year. So I'm going to put her key up as soon. Pepper's away. I'm going to put her key up on the Facebook group. Not till we're done, though. We still got a few more of these to do. Okay. And by the way, like if you couldn't do A, like 9A, you just look at it and go, I don't get it, but you could do 9B. It's not cheating to come down here and pick up the answer to 9A. Say, okay, I know 9A is 3.26. And then just say, I'm going to now use that answer to answer B. Okay, that's legal. It's legal on the AP exam as well. But there you don't know what the answers are. But on the AP exam, if you get to part C and it requires an answer from part B, which you couldn't do, you can say something like, assume acceleration is 2 meters per second squared. You can just say that. Like here, you could say, assume time is 4 seconds or something. All right, but anyway. Oh, Pepper woke up. So 9b says, how many meters does the car travel during the negative acceleration? Part A, we did that when using, without giving too much away. There's V final, there's V naught, there's A. We're trying to find time. So T then would be V final minus V naught over acceleration. You have to convert some units, but it's fairly straightforward for that. And then it says how many meters. You know, you could use the second orange to solve this, but in class, I use this one. Delta X equals V bar times T. I thought that was a little faster, a little easier. Well, let me turn off that grid view. Okay. So, the V bar, because there's only two velocities, that's simply the average of those two numbers. But then you have to convert it to meters per second. And then you multiply that by the time, 3.26 seconds, and you have your answer. Okay, that's the way I would solve. That's the fastest way to solve it. Okay.
I have a question.
Yes.
So on number 9A, why would 157 be V final instead of V naught?
Oh, duh. Yeah, you're right. I was not thinking. Zoom point for that. That's good. You're right. I think we said that in class because it goes from. You're right. You're right. It's slowing down, right? Yes. Oops. Well, I hope I mentioned that in class. Oh well. As soon as I get too lazy. Yeah, right. That is V final. And so you're going to get a negative. You go, uh-oh, I get a negative time. No, you don't, because you got a negative acceleration there. So that's V final, and that's V naught. Yeah, so time will end up still being positive because you have a negative over a negative. Yeah, negative over negative. I'm going to give you two Zoom points for that one. That's good. And no one really had a question on 10. I think people did 10 okay. The only thing is on that one. Go ahead.
So for the equation, like how would you rearrange that? Because don't you use the second orange equation?
We doing 9B?
10.
Oh, 10. And this one is 2,000 meters. Just make sure you don't say 2 kilometers. Bullets fired. This is going to turn the acceleration to the. Oh, okay. This did cause some issues today. Thanks for reminding me. I'm trying to get to something else, but we got to do this. So that's probably worth. And I had a couple kids in at lunch doing this. So we have delta X equals V naught T plus 1/2 AT squared. And I'm trying to solve this for A. So it's not a simple, thing. So in order to get the A by itself, I got to kind of go at it methodically. And the first thing I'm going to do is I'm going to get rid of addition, you subtract. So I'm going to go ahead and say that then delta X minus V naught T equals 1/2 AT squared. Okay. I'm not done yet, but I'm getting closer. It's like when I was a kid, we didn't have the internet, so we played with sticks. And we'd throw a bunch of sticks in the dirt. And then the goal was to get one stick, leave just one stick there. And so you had to pull the sticks. The sticks were all intertwined. So you had to kind of reach in to pull sticks out without disturbing the pile, kind of like a poor man's Jenga. And so that's what we're doing here. We're trying to reach in and pull things out without disturbing the acceleration, without disturbing the A. So we got to get rid of everything around it without messing it up. So now I'm going to multiply both sides by 2, and that'll get rid of the 1/2. And then I'll divide both sides by T squared. And so I end up with 2 parentheses, delta X minus V naught T divided by T squared equals acceleration. And by the way, this used to be my first couple of years of teaching. This was the 4th orange equation until we realized, oh shoot, that's just the second orange equation rewritten. And I stopped having them do that one because we don't really need it. You can just rearrange the second one if you need to, like in this problem. So that's acceleration. Now, I had a couple of girls, this has got to be 15 years ago now, that got A's in my physics class, but they were very concrete, very nice girls, very concrete, meaning that they couldn't think abstractly. I mean, at all. And so they were amazing memorizers. They would memorize every equation. So like in their case, they would memorize this. I didn't give them equation sheets back then. So they would memorize these equations, and they first get their test. They would spend the first 5 minutes writing down equations. But the problem is they couldn't apply it, and they just did horribly. You know, I mean, they ended up doing like an extra credit and stuff. They did okay, but and then they took AP Physics. Oh no, don't take AP Physics, but they did. And they took the AP Physics exam. I just kind of held my breath for their results because there was no safety nets. And you know what they both got? 1. 2 years of physics, and they both got a 1 each got a 1 on the AP Physics exam. I mean, I felt horrible, but I could predict that happening because they could not think. So I don't want to just give you an equation like this and treat you like the twins. They were twins, and treat you like my twins. I learned a lesson there. That's one reason why we started deriving, because you got to know where these things come from and be able to handle any situation. It's not just plug and chug. Doesn't work. You're gonna get a 1 on the AP exam. You're gonna flunk physics in college. So, yeah. By the way, before I forget, the homework tonight, we're moving on, but the homework tonight is 5, 6, and 11 for more dolphins. Don't do 12 yet, okay? We're going to do 12 together tomorrow, okay? Don't do 12. But I think 5, 6, and 11, I think unless there's some bugaboos I'm not thinking of, they got some goofy numbers, some kind of weird numbers, but I think they're all, the physics is okay on those. Okay, I want to go back, though, and spend the rest of the time we have, I think air time's about 35 minutes. Spend the rest of the time working on 5C and then starting 6, okay? Because we're back to the bullet in the barrel. This is for virtual. Okay, we're back to the bullet in the barrel. And we're supposed to plot acceleration versus time, average acceleration of the bullet in the barrel. Well, we already figured it out to be 225,000 meters per second squared, this ungodly huge number for the acceleration of the bullet. And we talked about G forces and G, and that'd be 22,000 G, and that's crazy. But that is what a bullet goes through in a barrel as it's in a core as it's going through the shotgun. Well, 5C then has us plot that. Well, anytime you plot, this is called a bar. It's really a bar. Anytime you plot a bar, be it V bar, be it A bar, be it F bar, which we will start plotting second semester, forces involved in something called impulse. You plot the F bar. Those are always flat. Okay, they're not instantaneous; they're flat. So this acceleration, we already know what it is. Now I made these units because I didn't want to write the number 225,000, 200,000. So I just switched the units as for convenience on this to kilometers per second. So it's 200. So 225,000 meters per second squared is 225 kilometers per second squared. Okay. So I simply go across 225 about, approximately, until I get to 2.7 milliseconds approximately, because that's how long, see the 2.7, that's how long it was in the barrel. We figured this out the other day. Okay, so I got that plotted. Easy peasy. All right. And then I asked them to go ahead and find the area under the curve. So I'm going to let you do that too. You now find the area and give it to me. Give me the area in terms of meters per second. Meters per second. What is the area under the curve I'm going to color it in while you're figuring that out. What is the area to the curve in meters per second? You need a calculator on this one, I think. Oh, I gotta make this look nice, actually. Area under the curve. This is one of those problems that's on a test. And tomorrow we'll show you a really good expansion of this one. I like these because it kind of forces you to think. I don't look for physics problems that I used to, that just kind of got the basics, F equals ma, work equals force times distance. We will do those. But I more like want to get you to think, be able to think like this, and put you in a situation where you got to think. Okay, so what'd you get for an area there? In meters per second. So in other words, this you're gonna have to make this you're gonna have to make this height 200. This height will be 225,000 meters per second squared. And this base, if we're going to be in, we're switching to MKS system, okay, meters, kilograms, seconds. And I'll say, okay, let's switch to MKS real quick. That's what I mean. I mean meters, kilograms, seconds. So put everything into fundamental units, not milliseconds, but seconds. And this now is 0.0027 seconds, okay? So if you multiply 0.0027 times 225,000, what do you get?
I got 607.5.
Okay, you got 607, right? 607. And what are the units? 607 what?
Kilometers per second.
Well, we switched these units to meters per second squared.
Oh, right.
Yeah, we kept these in seconds. So when you multiply that, what do you get for units? If I take meters per second squared and I multiply that by seconds, what do I end up with?
Meters per second per second per second.
No, that's if I divide it by seconds, but I'm multiplying by seconds.
Just meters per second?
Yeah, just one of the seconds goes away. So I end up with meters per second. 607 meters per second. Now, that is the velocity. In fact, that is the final velocity. And you say, wait a minute, Mr. Askey, you're wrong. The problem had the final velocity as 600 meters per second. Why didn't we get 600 meters per second for an area? You want to venture a guess? They didn't like this in class. They thought I was lying to them. Well, why didn't I get 600 then? Because remember that we didn't talk about this in class, but remember, I kind of blew through it too fast. I get in a hurry. Every time, you cannot rush physics. Every time I get in a hurry, I pay for it. Remember, we said the graph, I'm thinking trio now. And so, hold on. Let's go back. I have this already queued up. Okay, I'm thinking trio right here. So if we're in the trio, this column, and I'm doing A versus T down here, that's flat, but V versus T. So the area, remember, as you go up, as you go to the graph above, that's area, right? So this is showing what we're seeing here is, we're seeing right here, as I go left to right, as I'm moving left to right here, purple. As I'm moving left to right, sorry, I got the spinny ball up here. Buffering. Okay, as I go left to right, this is accumulation, but this time not of position, but accumulation of velocity. Let's talk about that tomorrow in class. Calculus. Accumulation of velocity as I go left to right. So if that bullet is accumulating velocity as it goes to the barrel, if we know it comes out at 600 meters a second, so why on earth did we get 607? You better check your numbers, girl. No, it's not that. She didn't do it wrong. That's what everybody got in class. So why isn't it 600? You know why? Because of significant figures. Because of round off. Because we rounded that time. We rounded two things. We rounded the time to 2.7 milliseconds, and it probably goes further than that. And we rounded this acceleration to 225,000, where we just did 3 digits, 3 sig figs. If we had gone all the way to 6 sig figs, and then we said like 2.68, whatever it really is, we would have gotten 600. Okay, so you can go back and prove it. I mean, that's cool. Prove it. If you don't trust me, prove it. But it's really 600. Okay. All right. Now, I promise we're going somewhere with this. If that's 600, this is wrong because, for one thing, and I have a gun somewhere around here, but I'll probably get in trouble if I pull a gun out and start showing you stuff. So let's say that I have I used to, back in the, sorry, I pulled my cord out. Let me do that again. I used to, well, actually, I don't want to. Okay, we're sharing the screen. You guys see the screen again? I lost my cord. You can see it, Sophia?
Yes.
Okay. So I used to actually I had bullets in class, and we'd talk about the different kind of shells and all the physics of bullets. And this is like 15, 20 years ago. I get fired now if I brought a bullet to school. I used to wear a bullet around my neck because I'd hold it up and show. Anyway, so I need a tube or something, but I don't have a tube. Anyway, so as that bullet, the bullet, when it's in the chamber, when it starts, its initial acceleration, it's a V naught is 0. Its initial acceleration is 0, or close to it. Initially, let's go a different color here. Let's go red. All right, so initially it's at 0. And then when the bullet leaves the barrel, of the gun, remember what is causing the bullet to accelerate? It's that expanding gas behind it, right? So once that bullet, and it's all that pressure that builds up, and this tremendous amount of, the atmosphere, we're in 1 atmosphere of pressure. I don't have that right on top of my head, but it's probably, I don't want to make a fool of myself, but you can look it up. But the pressure inside a gun barrel is probably 200 atmospheres or something. I got an old student that's a gun nut now. I can call him up. He'll tell me. Anyway, he's a good guy. I'm kidding. He's a gun nut. So once the bullet leaves the barrel, there's no more pressure. Theoretically, right? All that pressure, all that built up gas just kind of spews out and the bullet's gone. So when the bullet, in fact, you can tell sometimes it's a way to work a physics problem, is when the bullet reaches the end of the barrel, the acceleration is 0. So here at the end, the acceleration of the bullet is 0. It has to be 0 there, and it has to be 0 here. So this graph is wrong. But remember, this is an average. If I want to plot the instantaneous acceleration of the bullet, it's not going to look like this. It's going to come up. It's got to start at 0, end at 0. But the thing is, it's going to be a curve, and under the curve, it has to have an area of 600 meters per second. Because I had the kids kind of guess. Why don't you guys draw what you think it looks like? Here's one other thing. If you ever guys have been to I've all seen fireworks. And when the fireworks go up, they go, psh, they go up and they go, if you can see me at all. Yeah. So they go up, they go, psh, right? They come up, they go, psh, but they come out when the explosion occurs. And I was watching fireworks in July, and I actually took some video of them. I ought to probably show it to you, maybe if I have the cuts for tomorrow to remember. But you watch those fireworks, you watch them in slow motion. They initially come out really fast, and then they kind of trail off slower and slower and slower. And that's the way all explosions are. So in other words, the acceleration of particulates, of shrapnel, whatever it is, in an explosion is front loaded towards the beginning of the explosion. And there's something to do, it has to do with something called inverse square law. But it's why light, I'll forget it. We'll get to that later. But as they come out, they slow down. So my acceleration for this graph has to be front loaded. So I wouldn't let the kids do this, you know. Some just said, well, it must look like this, then it comes up. Oops. They said it comes up and it comes down. No, that can't be it, because it has to be front loaded. It has to be skewed towards the beginning. So the graph needs to look something like, how about something like this? Comes up, skewed towards the beginning, comes back down. Now, what's wrong with that? That's getting closer. What's wrong with it? Can anybody see the mistake? The mistake has to do with the area under the curve. Notice the blue area. Well, the area under the red curve has to equal the area under the blue curve. So I didn't go high enough. Okay, so I'm going to come back here. Oh. I'm going to cheat. Check this out. I'm going to take a scissors. Oh, no. Forget that. No, let's get rid of that. All right, instead, I'm going to give it a guess here. Okay, up. And then down like that. How about that? So I'm going to call this, I'm going to say this is what the graph really looks like. And then you look it up, you find these kind of graphs. You can look this kind of stuff up. Ballistics, acceleration of bullets inside barrels. They do it for tanks. They do it for, because you do all these kinds of studies, because we're a warring society, plus, money and all. But they do these kind of studies on mostly big guns. But they have to make the barrel inside the core has to be able to withstand this kind of pressure. All right, so a lot of that's pressure's front loaded. So if I cut this out, I tell you, I'm almost done here, but if I cut this out here, cut out this, I did this in class, so I'm not just making this stuff up. If I cut this out and then kind of turn that around. Oh, see, when I do that, it screws it up. Oh well, that screwed the area up. Oh well, you get the idea. And then I cut this out. Oh, sorry. I gotta get better at this. Okay, when I cut this out, this is a new tool, a new toy I'm starting to use. Nuts. When I cut this part out and then add this, there we go. And then add that to that. See, it's about right. Yeah. So that looks acceptable. Okay, so the point is that, okay, so then the last question on this is over here. It says, would this most likely be an example of a quartet where jerk is constant, or a quintet where snap is constant, or a sextet where crackle is constant? Well, now let's go back to this thing right back here, right here. And so, in other words, which one of these fits? Now, I didn't put a sextet up there, but a sextet would be what? There. A sextet would be would look like this. Sextet, sextet, I guess, would look like this. This buffering issue is going to kill me. Okay, so quick shaky sketch here. The sextet looks like this, where this is flat, linear, parabolic, cubic, fourth power, fifth power, and the question is, which one of these works best? And this is where this crackle, crackle. And for acceleration, obviously it can't be a jerk situation because look, in a jerk situation, acceleration is linear. So that can't be it. In a snap situation, acceleration is parabolic, but I'm getting a feeling that's probably more than parabolic. It's probably cubic. In other words, you can take any kind of function, you can keep taking derivatives. I don't care how complicated it is, and you'll eventually get a flat line. You know, this is a very complicated function here because here we have x equals kt to the fourth. Here we have x equals kt to the fifth, and then plus something k to the fourth, plus something k to the third. This long, it's a fifth order equation, which is extremely complicated motion. Okay, so I think it's either a snap or a crackle. I think a bullet, just from my educated guess, a bullet inside a barrel is a snap or a crackle. Okay? Whew. Oh, a lot of work. I don't know if I have the energy to do, we got to quit anyway. To do number 6. We started 6 in class. It's not homework. Don't worry about it. We'll do 6 A and B tomorrow. We'll knock off the 3 hardest questions, 6A, 6B, and the last one on the next sheet. So tomorrow's gonna be kind of a hard class. But I'm exhausted right now. You probably are tired listening to me. So we're gonna call her good for now. We'll pick up 6 tomorrow. Let me turn this off. The sharing. All right. Anybody got a question? Talked a lot about guns. Huh? I promise you I won't sit and talk about guns all the time. Okay. What's coming up? The thing you got to do, you got to submit. You got to, just housekeeping here, you got to submit the Girl in the Jeep, the 213 on Sunday by midnight. Watch the video on that. I had finally had my last person come in yesterday at lunch and finally took that test 2A. So now I've got them all and I've graded most of it. I got a grade. I'm on problem 6. I got a grade 6 and 7. I got to write a recommendation tonight or 2, but I will grade that starting tomorrow. I'll finish grading those and those will be ready. Those will be done by Sunday. The grades will be in the grade book by Sunday on the test 2A. That's 150 points. I will then start black and blue, allowing you to do black and blue, which means you all, my virtual kids, will have to come to my porch, and I'll set those tests into your slots so nobody else sees them. And if you don't know what I'm talking about, there's a filing cabinet in there, and you don't have to come do it. If you end up with a 130 out of 135 out of 150, you go, I don't want to mess with going to Askey's porch, then you don't have to. Okay, it's not required, but it's just some people they desperately need that black and blue points. Okay, and that starts Monday, and it'll go Monday, Tuesday, Wednesday. Got them back on my porch by, let's say, 8:00 p.m. Wednesday. Okay, then I'll get those grades in there on the weekend, and then you'll kind of have a pretty good idea what your final grade is going into the final. And you don't take the final if you have an A or B. And most of my virtual kids have an A or B. If not, you need to get that grade up, get it to an A, B. They don't have to worry about it, because the final is going to be a pain in the butt, because here we go again, with papers, and what a mess. So I prefer that you just, you do have to take test 2B, which is Wednesday the 16th. And I think I will give it to you. I will open it up to you. We'll do the old PDF thing again, or my front porch on Thursday, the 17th. Okay, you'll have Thursday, Friday. That's it. You got to get it to me by Friday, because that's it. That's the last day. Okay, so I'm just thinking ahead there, but we'll talk more about that later. Okay, other than that, I'm going to turn record.